Need to run to the bathroom again?
I
All right, so we're going to cover 5.7, which is on the second derivative test. Be very careful with this one. I want you to write kind of in shouty caps that this is a test for most kids, not most, but a good chunk. When I have them use the second derivative test either on an actual exam or on the AP exam, they think second derivative and they think concavity, and they think they're doing a test for concavity. That's what you just did, was called a concavity test. You made a sign line for the second derivative to decide if we're concave up or concave down. The second derivative test has the same result as the first derivative test. It's a test for relative maxes and mins. That's what it's a test for. I'll tell you how the test works in just a second, but I want to, on this first nice easy polynomial one, I want you to split it, and we're going to do the first derivative test over here. Pretend I can write the word test. And we're going to do on the other side the second derivative test. We will get pretty much the same answers. They're both for finding relative maxes and mins. They both start out the same way, okay? For the first derivative test, I'm eventually going to make a sign line for the first derivative. So we'll go take that first derivative, and we'll say it's negative 15 x to the fourth plus 15 x squared. The second derivative test starts exactly the same way. You take a first derivative, okay? So far the tests are identical. Let me know if I'm writing too fast, but pretty straightforward test. You guys tend to write fast. For the first derivative test, we find where does the first derivative equal 0. All right, so we've got a negative 60 x cubed, right, plus a 30x. Am I good? I feel like I've got something goofy.
Yeah, are you just trying to take...
Oh, I already took the first derivative.
Yeah.
I took the second. I'm like, what? I was looking at this as the original function, not this guy. So this one, I'm going to factor it to figure out where we equal 0. I knew something was off with it. All right. So I'm finding the critical values. That's the same thing you do for the second derivative test. So far, they are still identical. All right? So no difference. We good so far? For the first derivative test, I now make a sign line on which I put my critical points. My critical values are things that make the derivative equal to 0 or make it not exist. And I put them on a sign line, and I go 0, 1, negative 1. How are we doing, Alexa? You good? For the second derivative test, I also find those critical values, but they don't go on a sign line. All right, so far, take the first derivative, set it equal to 0, find critical values. Take first derivative, set it equal to 0, find critical values, and put them on a sign line. Okay, then for the first derivative test, what we do is we check and see, we analyze the first derivative test and see where the function's increasing and decreasing and where it turns. So on this one, I'm just going to go plug in a negative over here into this derivative, and it'll make the lead number negative always because of negative 15, so it doesn't even matter. That's going to be a negative times a positive, correct? And why did I put a 2 on there? Why didn't somebody tell me it's plus or minus? It still doesn't matter. It's a negative times a positive, which is a negative. Understand what that tells you about the function. For the first derivative test, it means the function was going downhill. Okay? And then it hit negative 1, and maybe it hit a plateau and continued to go down, or maybe it turned and went back up. You have to go test it. So when you put in, like, say, a 0.5 in for your x, it'll be a negative times, and a half squared minus 1 is negative. I now could classify negative 1 as the location of a relative what? Min. Okay? Rel min. And I don't know what it is, what the rel min is. I'd have to plug it back into the original function. But there would be a rel min at negative 1. When I go test out what happens at positive a half, I also end up getting a negative times a negative. What does that mean happened at 0? I know the function went down, then up, then hit a what at 0? A plateau, right? And then I have to see if it continued to go up. Maybe there was a double plateau, right? Or maybe it went back down. And when I put in, like, say, a 3, that's going to go negative. So this one right here, we would classify as like a plateau. There was a critical value, but there was no change in increasing to decreasing status. This guy right here would be the location of a rel max. That's from earlier this week or last week, right? This test over here, our new one, I'm going to now go back up and show you the difference. It still says that we need to find those places where the derivative equals 0. I've just done that, so this is a check mark. Then it says I'm supposed to look at the concavity there, so no sign line. What I'm going to do is say, well, what is the second derivative at 1? I'm going to go plug this guy into the second derivative. And when I do that, and I put a 1 in for my second derivative, I better go take it, right? My second derivative would be a negative 60 x cubed. I'm just doing the derivative of this first derivative, plus 30x. Doesn't really matter what it is, you just have to know if it's positive or negative. When I put a positive 1 into this expression, will it end up being positive or negative? Negative. I want you to go less than 0. So what this first part did is gave you where there was a derivative of 0 or a horizontal tangent line. This is saying that the second derivative is negative, which means you're concave down at a place where there's a horizontal tangent line. What does that mean occurred at 1 if we are concave down at a place where there's a horizontal tangent line? A rel what? Max. And do you see how that gave us 1 too? So rel max. So up here, if the second derivative is positive, we're going to be positive, think smile, up like a cup, we will get a minimum. If the second derivative is negative at a place where there's a horizontal tangent line, we will get a maximum. Here's actually what some kids commonly do. They see that they get a number bigger than 0 and they think bigger is a max. But the second derivative being positive means you open up like a cup, so that point of horizontal tangency is a minimum of the function. Does that make sense, guys? So let's go do our second derivative. Notice there's no sign line here. Now if I do my second derivative at negative 1, so again I got to go back up here and pretend I'm putting in a negative 1, this will become a positive 60 minus 30. I am now greater than 0, which means I curve up like a cup, which means that place where there's the horizontal tangent will be the location of a rel min. What do you think? Make sense? The last one up is 0, and when I put 0 in to the second derivative, I get 0 out. If you go back up to the actual test, does it say anything about equaling 0? And it's no, so I'm going to have you answer that one. If the second derivative equals, at the critical value equals 0, this test is inconclusive. You actually know what happens there from the first derivative test. You told me there's a plateau, right? So the first derivative test is a little stronger because it tells you exactly what happens at these places. Okay, but look at min, max, plateau. Min, max, don't know. Min, max, plateau. You see how they have the same results? All right, so let's go to the next page. We're going to practice reading a table. And we're going to do a full FRQ reading a table. So you have 3 different levels for your function. You're going to hear me saying a lot next week and after Christmas when Mason goes, I didn't get that. I'm going to say, you're on the wrong level. And then Kate just goes, well, I didn't get it to be increased. And I'm going to say, you're on the wrong level. So understand what these levels are telling you different information about the function. If all I told Emma is that at -3, f of -3 is -7, this is what she knows about the function. There's a dot. And if I say, Emma, what does the function look like? She'll go, I don't know. You know what I mean? It's like me saying the main character in this story is Bob. Isn't that a great story? See what I mean? So those are just dots on the function. This next level tells me what the function is doing at that dot, whether it's going up, whether it's going down, or whether there's a turning point. So it's a little more in the story. Because this is positive, what's happening at 1? It's going to be increasing, correct? So this tells me dots on the graph are the main characters of the function. This tells me how those characters are connected, whether I go up to get to 1 or down to get to 1. So we say increasing, decreasing. The second derivative tells me the curvature there. So not only am I going up, but am I going up at a decreasing rate or going up at an increasing rate? See what I mean? So it gives me a lot more. Sometimes we say it tells us curvature. You just said decreasing, right? We're concave down like a frown while going uphill at -7. So I know this is part of some concave down increasing function. Does that make sense? So those all tell you different things about the story. Part A says identify all x values where there's a relative minimum using the first derivative test. So for the first derivative test, I'm looking for critical values. There's one. There's one. And then Ben might say, well, how do you know that this didn't go down to -2 and then up to 5 and down to -9 and a whole, like totally oscillating back and forth between these two? And he'd have a really good argument if it didn't say this. Right? It says there's only 2 zeros. So you are 100% convinced that all these numbers in here must be positive. Because otherwise there'd be another 0. Does that make sense? So it actually is a very good argument. If that wasn't there, you'd say, I don't know what's going on between the dots. Right? Now, for there to be a minimum, what has to happen at your critical value? For the first derivative, it has to go from what? Negative to positive. The function has to go from decreasing to increasing. Where does that happen? At x equals 3, right? By the way, this is also a critical value, right? But the function was going up and then continued to go up. I don't know what it was. Maybe it was like that. I don't know. At x equals 3 because, then you have to tell me why. This is where you have to be careful. You can't say because it changes. You can't say because f prime changes signs. What do you think you have to say? F prime what? You have to be very specific. Can't use it because we have 3 levels, right? It could be it. And it's not because it changed signs. It's because it specifically went from what? -2, exactly what Alexa said. F prime changes from negative to positive. How's that? We good? What do you think, Cage? Now it says a relative maximum, but it says I'm supposed to justify using the second derivative test. So you still have to look for those critical values. Bing, bang, boom. But then you have to go to the second derivative and look at curvature there. This has what I call curve depravity, right? This is concave up like a cup. So that's the location of a minimum. This is concave down like a frown where there's a horizontal tangent line, right? So where's my max? At x equals -1, but you don't say because f prime changes from positive to negative. That would have been this test. You have to state 2 things. You have to say because f prime of -1 equals 0, or you could say because -1 is a critical value. So I know I have a horizontal tangent line, and at that horizontal tangent line, the second derivative is negative. I love it if you word it like that. As an AP reader, this is my favorite paper to come across my desk. You want to know what the least favorite is? There is a relative minimum at x equals 1 because f prime of -1 equals 0, which means there's a critical value there. So using the second derivative test, I plug it back in, whoops, and I got f prime of -1 to be negative, which means the function's concave down at the critical value, so there must be a max. Imagine reading 100,000 of those. So you need to be very clear, no pronouns. You need to say, I know there's a critical value, and I know I'm concave down there. But write it as succinctly as possible. Does that make sense, Cage? Or you make your reader really grouchy. All right. Now this says points of inflection. What part of the story does that deal with? The second derivative. Okay. And what in particular do we need the second derivative to do? Don't say equals 0. Change signs. Exactly. And it doesn't matter positive to... So I lost the stem of the problem, but where does the second derivative change from either positive to negative or vice versa? At x equals 1. And let's do because. It's because f double prime, right, changed signs. Good enough. It's easy to read. We're not going to do this last one because I think we've mastered this question. But when I ask you to write an equation of the tangent line, what level do you need? You need a what? Point, so you need to be on the f level. And you also need a slope, so you need to be on the f prime level. Nothing to do with concavity or anything. All right, so we don't need to do that. You guys, I want you all to go to, we still have about 11 minutes. I want you to go to the first one where you have to use the second derivative test, just so you run through it on your own. Oh, sorry. Yeah, it'll be number 9. It says find all critical numbers and use the second derivative test. Will you be making a sign line? No! No candidate table either. That's for absolute. So there's lots to keep straight this chapter, but none of it's very difficult. The analytics of it aren't too bad. You need to find the critical values and then the curvature there. Concave down, max, up, min. Let's see if this recorded. It didn't pop up a little. You guys, it did. Yay. All right, so those of you watching the video, they're going to try number 9. They're going to check it out with each other. You guys should try it and check it on the key. And then before I turn this off, and I'll tell you guys too, Carissa, can I steal your packet? Just because there have been so many absences, I've said it before, so if you haven't been absent for a while, you can just tune me out. But so far, you should be done with 5.1, all of it. 5.2, we're not doing any of it. So she already wrote, don't finish on here, but I'm just taking, 5.2 we did elsewhere, so I don't want you to think you need to do that. 5.3 and 4, we did all of it, and I checked it already, so she's got my signature on there. 5.5, I said only 1 through 9, so I don't want Krista to think she has this to finish. Only through 9. So you might want to just, and we'll never go back and do those others. You might want to cross off 10 through 15. Today's is all of it, 1 through 14. So I'm going to pull a stop at the bottom, just so you're 100% sure with all these absences. You can take it back, hon. There you go.
Which one is 1 through 9?
1 through 9 is on 5.5.
Okay.
Yeah, stop at 9.
Oh, that was Wednesday's.
Yeah, yep. I'm going to